Greetings and welcome to the new calculus channel. My name is John Gabriel. So in this video I'm going to talk about the symptom of phi, which is also known as the golden ratio. So how do we arrive at the symptom of phi? Well, we arrive at the symptom of phi when we have a special kind of right angle triangle. Okay, in other words, the special triangle has one side x, the other side 2 times x, and the hypotenuse is root 5x. So that means if we try to measure root 5x plus x, okay, we try to measure root 5x plus x with this side, we end up with the golden ratio, so to speak, the golden ratio 1.61803. Now, because we're talking, there is no such number as phi, by the way. This 1.618 is a failed measure or an approximation of the constant phi. What I'm saying is this: if we choose any particular triangle, it doesn't matter which one, the ratio of this red line to this blue line, red line to the blue line, will always give us phi. And you might be saying, well, why am I getting 4.05979 here? Because my unit here is not 1. It's 2.50909. To see what happens, I don't actually want to do that. Let's go to graphics and say grid. Let's show major grid lines. So if we go over there and we set that to 1 like that, then the unit is 1 in this case, and then of course both results will be the same, okay? But in any case, it doesn't matter where you go, because any right angle triangle with this property, that the one side is twice the other side, will result in the symptom of phi. Okay, so all math professors and mathematics teachers do not understand the difference between three very important terms. One is magnitude, which is not a number. The next one is ratio, and the final one is number. They have no clue what those three means. And as a result, they have no clue what it means to measure. Okay, so their very superficial understanding is one of a number line, which is also incorrect, because you cannot reify anything but a rational number line, and only certain rational numbers, not all of them, the ones you choose, in other words. So the word commensurate derives from Latin commensuratus, okay, which means measure together, or of the same measure. And this Latin term is composed of the prefix com, which means together, and mensuratus, which is the past participle of mensurare. And maybe I'm not pronouncing those well, but mensurare means to measure. And so mensurare itself comes from mensura, however they pronounce it, meaning measure, which is related to metiri. Okay, and the Latin verb metiri has Greek roots, metrisi. Okay, so metiri and metrisi. Metiri is a verb, and metrisi, that's where it comes from, the Greek word. So the etymology of commensurate reflects the idea of measuring together or having a common measure. Now, you cannot talk about commensurability in geometry, because as I've shown you here, it doesn't matter what right angle triangle you have, okay? Every such ratio is commensurable, meaning that if you wanted to measure this red line with the blue line, you would take this line plus whatever is left over and concatenate it, and there you have the measure. That's geometric measure. But in algebra, we use something called an abstract unit, and as you can see, if we vary the angle, the unit size changes, doesn't it? Okay, the unit size changes. And so in the Greek, commensurate comes from the word analogous, which means in proportion to or compared to. Okay, so these terms and concepts are very important for you to understand, because without these, you cannot really understand the foundations of mathematics, which are Euclid's elements. All you're doing is propagating the stupidity of the people who came after the ancient Greeks, who weren't able to understand the elements or the works of Archimedes or the conics of Apollonius or many other things, or the parallelism of Thales. Now, you'll find in this video here, which I'll place a link to, Symmetry of the Circle, why you can do all arithmetic, all the 4 basic operations of arithmetic in geometry. I'll also place a link to my most recent video before this one, which is Arithmetic Without Numbers, which shows you how through parallelism the Greeks were able to do everything. In other words, they didn't even have an idea about number. Okay, they couldn't even count, but they used the idea of parallelism. And if you really are a math lover, then this article here is for you to study. It'll take you probably several weeks if you're a professor. If you're a high school student, it'll probably take you a week or so. It's just so because a professor's brain is usually filled with so much crap that they struggle to understand even the most simple concepts. And the same thing goes for your math teachers. So I'll place links to those. And if you're not already a subscriber, become a subscriber. Click like, follow me on academia, tell your friends about this, your teachers, your professors, everyone you know. Spread the news. This is priceless knowledge which I'm sharing with you. I'm John Gabriel, and this is New Calculus Channel. Till next time, goodbye.